Okay, one more time here for Shaylin and anybody else absent. Since it wasn't plugged in, we'll try again. So, trigonometry. Okay, sound brilliant now, class. Trigonometry is the study of what? Triangle measures. And when, that's your one and only trip out of this room.
The measure of triangles.
Or the measure of triangles, whichever way you want to do it. So, we were just talking about you can put an angle on a coordinate system. Where do you always put the starting side of the angle? At the origin and along the x-axis. It's called the initial side. When your angle ends, that's called the terminal side.
That's where it terminates at.
Okay, and then we just had this lovely debate about what are all the Greek letters, because when we work on a coordinate system, we use Greek letters to represent our angles. Okay, class, now, how big can an angle be? It can be infinitely big, positive, and negative. As you can see down here to the right, we have an angle of 1,080 degrees. It went around 3 times. That is perfectly possible. Angles can also go backwards. In this case, we went backwards 135 down here. Okay, so when I label my quadrant lines, if this is a 0-degree angle, what's up here?
90.
That's a 90, which means this is 180, 270. And technically, the back to 0 is 360. We can keep going around, but those are the 4 you're going to work with the most is what your quadrant lines are labeled with. Okay. Our deal is sometimes if I give you an angle, particularly an angle larger than 360, in order for you to be able to work with it, you need to figure out what angle it is the same as that's less than 360, and those are called coterminal angles because they have the same terminal side. They end at the same place. So this is... No, you're not getting the journal for this because I have to have your portfolios turned in before we would ever get done the journal. Your portfolios are going to be due probably sometime late next week, and we won't be through this chapter yet.
Has no one ever tried stealing your portfolio?
Has anyone ever tried? I don't know. Do you think I leave it exactly the same year after year? I change the questions up because I have this very issue.
So are we going to have a test over this?
Are we having a test over this? Yes. Your last day of this class, which is a Tuesday, you have a test on it. It's not a full 100-point test, but it's a test.
You'll have to we're gone on that day, though.
It's a front and the back of a sheet of paper. Yes. And I know you have. It's close to a quest. Then you'll be coming in some other time where you're going to be taking a 0 on about 80 points. So, okay, if I want to do a coterminal angle of 880 degrees, I'm asking you, name me another angle that ends in the same spot as 880 degrees.
0.
Okay, well, first of all, what do you know about 880 degrees?
It goes around more than once.
It goes around more than once. So it's going to go around once is 360.
It's a 160-degree angle.
Around twice is 720.
Yes, that's correct.
Okay, so can I go a third time?
No, you can go 180 though.
So I know it's going to be, I need to know how much farther is it after 720. So I'm simply going to subtract 720 out of it.
160.
Okay, which 160 would leave me where? Actually, do you guys know your quadrant numbers?
Two quadrant.
Yeah. 1 starts here, you go around the circle 2, 3, 4, because we're going to talk about quadrants a lot with Trig. So yeah, this one 160 isn't quite to 180, so yes, we're going to end up somewhere over here, but not quite to 180. Okay, they want you to name a positive angle and a negative angle that end at the same spot. That one does. You already just found one. What's another positive angle that ends in this same spot? We just did it. 160, yeah. From there to there is 160 degrees. So therefore, that's
200 degrees. Negative 200 degrees.
okay. Why?
Because you got to subtract it from 360.
Yeah. To get a negative angle, I would have to start here and go backwards and end in the same spot. So this is, if you just will draw the picture of these, this is common sense. If that's 160 going in this direction, how much does it have to be the other way? Because you know a whole circle is 360. So if it's 160 that way, it means it's 200 going backwards, and you just need to put a negative on it to say, hey, go around backwards. Those would be your two coterminal angles. Is that a major big deal? All right. Then let us try another one. Suppose I was to give you negative 310 degrees, and I want you to name me a positive angle and a negative angle in the same spot. So first of all, you need to figure out where is a negative 310 degrees going to fall.
50 degrees.
Because if I'm going backwards, that means I'm coming around this way. There'd be negative 180. That'd be negative 270. So 310 is going to put me in first quadrant. So why is Caleb telling me 50 degrees all the time? Yeah. Wouldn't there be a 50-degree gap left there? So if that, I know that's 50 degrees, so that's your positive angle right there. It's a 50-degree angle. Now, how do I get another negative one, though? I need another negative angle that ends in the same spot. So, what do you have to do to get another negative?
Go around more than once.
You would have to, you'd have to go around more than once. So you'd have to go, okay, there's negative 360, and then I have to go.
Negative 360 to negative 310.
Exactly. You can just it'd be. Well, yeah. Sorry, but some people mess this up horribly. I have issues with this. Okay, so yeah, you went around 360 and another 310, so total you got 670. And all you do, the negative indicates that you went backwards. That's all you did, is you went backwards 670 degrees, so those would be your two answers. Okay, so when I give you the correct assignment sheet, you'll notice you have assignments in 4 different sections today. They're all little ones. That was the first section, coterminal angles. Yeah, little short things like this. Okay. The second one.
Okay, why'd you do
In
that?
your dreams. Are we done? Are you crazy? All right. Something you've been dying to know all year. Radians. You're going to be able to read the clock.
Oh, crap. I already know the reason. Oh, that clock?
That clock. You can finally read the clock. Oh, stop whining. This is not that hard, and school is not over. We're learning, honey.
This is math.
Okay, radians, degrees have a problem.
Which one are we trying to learn?
That clock. Yeah, we're going to the white clock. Okay.
It doesn't work.
That doesn't work. It'll give you so many decimals. It'll take pi 3.14. It'll take pi's decimal value. That doesn't work. Okay, why have another way to measure an angle? Why are degrees good enough? Well, can you take degrees? Can you take 30 degrees times 10 feet? I mean, does that make sense to take 30 degrees times 10 feet?
What would that even do?
Well, yeah, exactly. What kind of a unit would that be? A degree foot? A degree foot, that makes no sense. You cannot combine degrees with length and distance.
Why would you want to? I don't get why. Figure out for animals or something.
Okay. When we want to figure out, primarily it's dealing with circles, but if you're talking about particularly something spinning, and if I have something spinning, how fast is something on the edge moving? Think
Wind turbine.
okay, yeah, how fast is the edge of it moving? I need to talk about, okay, it's rotating at the center, so the angle at the center is changing, but what is the distance this is traveling? So I need to be able to combine the distance with how fast the angle is moving at the center. I need to be able to mix an angle measure with a distance. So they said, we need another way to measure angles, and I created what are called radians. Okay? A radian is pretty simple. Actually, no, my little blue point there is not quite right. A radian is simply, they said, okay, we're going to define an angle based on lengths in a circle. What's the most common length you use in a circle?
3.14.
But the radius. We use the radius all the time. So they said, all right, there's the radius. I am going to draw along the edge of the circle the same length as the radius. So I want this arc to be also the length of the radius.
So that's the length of 1 radian?
And then if I form an angle right there, that is a 1 radian angle. An angle whose arc is the length of the radius is a 1 radian angle. Okay. It turns out, you don't need to know this, but it turns out 1 radian is about 57.3 degrees, to give you a rough. When I do a 1 radian angle, I think, oh, a little less than 60 degrees. I'm going to show you a better way to relate the two of them, though. Don't use that one. That's approximation. Okay. What they actually wanted was a way to connect radians to degrees so we can compare them. So they said, hey, dude, let's set up a proportion here. I'm sure they said dude. I'm sure that was in their language back then. Absolutely. Okay, so they wanted... They wanted a connection here. So would you guys agree, we're setting up a proportion, so we know a 1 radian angle is related to an arc that's the length of r. Okay, now tell me what length do we know on the edge of a circle? Yeah, 360 degrees would be the same as, would be comparable to the circumference, right? Do we know a formula for circumference? 2 pi r, yes.
Pi radius squared.
That's area.
I was kidding.
We're doing circumference. Okay, so I have to have 1 radian is to r. I want to compare these two things.
Cross multiply.
Thank you, yes, I'm going to cross multiply. So 1 times 2 pi r is 2 pi r. And I have 360 times r then.
Wow. Wait, what happens to our RA?
Well, what's going to happen to the r's? The r's are going to cancel, aren't they? That's 360 degrees. So because I could divide the r's cancel. So really, 2 pi radians is equal to 360 degrees. Or we actually divide them both by 2 then. And to get rid of the 2, we'll be down to pi radians is the same thing as 180 degrees. If you look at the clock, and notice where 180 degrees is, what's written there? Pi. Because pi radians is the same thing as 180 degrees. Alright. So then, if this is pi radians over here at 180, 90 is half of it, right?
Yeah. So it's pi over 2.
So it's pi over 2.
So it's 2 pi on the bottom.
Not 2 pi on the bottom.
It's going to be 3 pi over 3 pi divided by 2.
Because it'd be 1 and a half. 1 and a half is 3 halves. So it would be 3 pi over 2. Yeah. And then all the way around that's 0 or it's 2 pi because you've gone completely around.
How do you get 0 with 2 pi?
Well, that can be an angle of 0 where it's totally flat, or it can go all the way around once, which would be 2 pi. So there you go. Now we understand at least the quadrant lines of the clock. If you simply, what you need to keep in your head, this is the relationship. Pi radians is 180 degrees. Oh, thank you. I'll say this and then I'll switch. The pi over 6, the first green one as you go up, it's right here. So how many degrees is pi over 6? If pi is 180 degrees. Pi is 180 degrees. Yeah, 180 divided by 6. That's maybe a 30-degree angle. Pi is 100. Pi radians is 180 degrees. Keep that one in your head. You're good. Okay.